The Gopher's Gambit, Survival Advantages of Artifact-Based Intention Perception by Cynthia Hom, Amani Shilos, Kevin Quinta, Cindy Lay, and George Montañez of Amistad. The Gopher's Gambit is one of 3 forthcoming papers studying the survival advantages of intention perception in simulated agents. The Predator's Purpose explores perception through target awareness, presenting a scenario where prey have varying levels of awareness regarding the predators around them. The Hero's Dilemma takes a more game-theoretic approach and explores different strategies for surviving an adversarial situation where the enemy may or may not attack. The Gopher's Gambit takes a step back and studies advantages of the ability to assess intention from artifacts in the environment. We use simulated gophers for our agents and present them with traps containing various artifacts. Every trap has a door, which if triggered by the gopher sends out a signal. This signal can be propagated through wires if properly connected, and then onto arrows, which fire and can kill the gopher. This can only happen if the trap is set up properly, but many are simply randomly thrown around pieces and are not intended to harm the gopher. In a non-functional trap, the gopher can safely reach and eat the food at the center, which it needs to survive.
Here we have the experimental setup. Gophers go through a series of 50 traps in a conveyor belt fashion, with each trap having a default 20% chance of being manually designed. Gophers can either starve, be zapped and killed by an arrow, or survive by going through all 50 traps. Each arrow type has a different percent chance to kill the gopher. By default, skinny, normal, and wide types are at 15, 30, and 45% respectively. Each set of our parameter values is independently run 10,000 times. The probability for our baseline gopher to enter a trap is 80% by default.
Contrary to baseline gophers, intention gophers use the intention perception algorithm to determine whether to enter a trap. Our intention perception algorithm uses artifact-based intention perception, meaning the gopher uses the artifact, the trap, to indirectly determine the intention of the other agent who left behind the trap pieces. Specifically, the algorithm assesses the structural coherence of a trap configuration to determine how likely it is that the trap was designed to kill the gopher. To measure coherence, we calculate the ratio of coherent connections to non-empty cells of the trap configuration. For each trap, the intention gopher calculates S of x, the surprise value of this coherence measurement, using the equation here, where x is the trap that is being assessed, and script x is a set of all possible trap configurations. P of x is 1 over the cardinality of script x, and f sub g of x is the proportion of all possible trap configurations with higher coherence levels than trap x. So, very coherent traps will have large S of x values. At an S of x value of 13.29 bits, which corresponds to an alpha value of 0.0001, the intention gopher rejects the null hypothesis that the trap was randomly generated and concludes that the trap must have been designed with an intent to harm the gopher. Since intention gophers avoid traps that they deem to be designed with the intent to be dangerous, they are often more cautious than baseline gophers, meaning that they enter traps at a lower frequency. In order to make sure that the benefits of the intention algorithm were due to intention itself and not mere caution, we created a cautious gopher, which enters traps randomly but with the same frequency as the intention gopher. From these graphs, we note that the intention gopher has higher values for almost all survival measures for these parameters, except for the graph in the upper right. This is because normalized food consumption is the amount of food normalized by the gopher's lifespan, so baseline gophers, which enter traps randomly and are often killed by designed traps, can have high values of normalized food consumption even if they have very short lifespans. We see similar trends here. The intention gopher, once again, has the highest lifespan and total food consumption across both varied parameters. However, for the same reason as before, the cautious and baseline gophers surpass the intention gopher at times in normalized food consumption. The stack plots on the right side of the slide support this general trend. We note that intention gophers are much more likely at all time steps to be alive, and are also more likely to die of starvation than of being zapped by an arrow.
We wanted to determine if an agent with intention perception had survival advantages over an agent without intention perception, the ability to detect intended configurations. We found that it does help survival and is highly accurate through statistical analysis of artifacts, and knowledge of intention can be exploited by artificial decision-making systems. Intention perception was helpful in the majority of our cases tested, but it was most beneficial when prioritizing safety over food consumption.